Hello everyone. The existence of different kinds of matter is due to different atoms constituting them. So today, let us discuss something more related to this in our lesson Structure of the Atom. Charged particles in matter. Atoms have three types of subatomic particles. They are electrons, protons, and neutrons. Electrons are negatively charged, protons are positively charged, and neutrons have no charge. The mass of an electron is 1 by 2000 the mass of a hydrogen atom. The mass of a proton is equal to the mass of a hydrogen atom and is taken as 1 unit. The mass of a neutron is equal to the mass of a hydrogen atom and is taken as 1 unit. Discovery of subatomic particles. In 1900, J. Thompson discovered the presence of the negatively charged particles called electrons in the atom. In 1886, E. Goldstein discovered new radiation in gas discharge and called them canal rays. These rays were positively charged. This later led to the discovery of the positively charged particles called protons in the atom. In 1932, Chadwick discovered the presence of particles having no charge in the atom called neutrons. Structure of an atom. First one, Thompson's model of an atom. According to Thompson, an atom is similar to a Christmas pudding. The pudding had positive charge and the electrons have negative charge were like plums on the pudding. He proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Rutherford's model of an atom. Rutherford's alpha scattering experiment. Rutherford allowed a beam of fast-moving alpha particles having positive charge to fall on thin gold foil. He observed that most of the alpha particles passed straight through the gold foil. Some of the alpha particles were slightly deflected by small angles. Very few alpha particles appeared to rebound. Conclusions from Rutherford's alpha scattering experiment. Most of the space inside an atom is empty. The atom had small nucleus having positive charge. The size of the nucleus is very small compared to the size of the atom. Rutherford's model of an atom. An atom has a positively charged nucleus at its center and most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in different orbits. The size of the nucleus is very small compared to the size of the atom. Defects of Rutherford's model of the atom. Any particle in a circular orbit would undergo acceleration and during acceleration the charged particle would radiate energy. So the revolving electrons would lose energy and fall into the nucleus and the atom would be unstable. We know that atoms are stable. The next one, Bohr's model of an atom. An atom has a positively charged nucleus at its center and most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in special orbits called discrete orbits. These orbits are called shells or energy levels and are represented by the letters K, L, M, N, etc. or numbered as 1, 2, 3, 4, etc. While revolving in the discrete orbits, the electrons do not radiate energy. Distribution of electrons in different shells. The distribution of electrons in the different shells was suggested by Bohr and Bury. The following are the rules for filling electrons in the different shells. First one, the maximum number of electrons in a shell is given by the formula 2n square where n is the number of shell, that is 1, 2, 3, etc. First shell or K shell can have 2n square, that is 2 electrons. Second shell or L shell can have 8 electrons. Third shell or M shell can have 18 electrons. Fourth shell or N shell can have 32 electrons, and so on. The maximum number of electrons that can be filled in the outermost shell is 8. Electrons cannot be filled in a shell unless the inner shells are filled. Here is the list of the composition of the atoms of the first 18 elements. Atomic structure of the first 18 elements. Valency. Valency is the combining capacity of an atom of an element. The electrons present in the outermost shell of an atom are called valence electrons. If an atom's outermost shell is completely filled, they are inert or least reactive, and their combining capacity or valency is 0. Of the inert elements, helium atom has 2 electrons in the outermost shell, and the atoms of other elements have 8 electrons in the outermost shell. Atoms having 8 electrons in the outermost shell is having octet configuration and are stable. If an atom's outermost shell is not completely filled, it is not stable. It will try to attain stability of losing, gaining, or sharing electrons with other atoms to attain octet configuration. The number of electrons lost, gained, or shared by any atom to attain octet configuration is the combining capacity or valency of the element. Example: hydrogen, lithium, sodium atoms can easily lose 1 electron and become stable, so their valency is 1. Magnesium can easily lose 2 electrons, so its valency is 2. Aluminium can easily lose 3 electrons, so its valency is 3. Carbon shares 4 electrons, so its valency is 4. Fluorine can easily gain 1 electron and become stable, so its valency is 1. Oxygen can easily gain 2 electrons, so its valency is 2. Nitrogen can easily gain 3 electrons, so its valency is 3. Atomic number and mass number. Atomic number denoted as Z. The atomic number of an element is the number of protons present in the nucleus of the atom of the element. All the atoms of an element have the same atomic number. Example: hydrogen atomic number is 1. Helium atomic number is 2. Lithium atomic number is 3. Mass number denoted as A. The mass number of an element is the sum of the number of protons and neutrons present in the nucleus of an atom of the element. The mass of an atom is mainly the mass of the protons and neutrons in the nucleus of the atom. Example: carbon mass number is equal to 12. Aluminium mass number is equal to 27. And sulfur mass number is equal to 32. In the notation of an atom, the atomic number and mass number are written as shown. Isotopes. Isotopes are atoms of the same element having the same atomic numbers but different mass numbers. Example: hydrogen has three isotopes. They are protium, deuterium, and tritium. Observe the examples. Carbon has two isotopes. They are carbon 12 and carbon 14. Chlorine has two isotopes. They are chlorine 35 and chlorine 37. Isobars. Isobars are atoms of different elements having different atomic numbers but same mass numbers. These pairs of elements have the same number of nucleons. Example: calcium, atomic number is 20, and argon, atomic number 18, have different atomic numbers but have the same mass number 40. Iron and nickel have different atomic numbers but have the same atomic mass numbers, that is 58. So this was all about our lesson structure of the atom. Our human body is made up of collection of atoms. Also many other things are made up of atoms. So knowing the facts related to it is very important. Thank you, students.